Okay, what we're going to talk about next is basically how to evaluate a function. For starters, just like we talked about before, f of x is equal to y, and how that, so normally our ordered pairs are x comma y. Those can also be represented as x comma f of x. So make sure you're aware of that. It's an important connection when you're using function notation to represent that. Now, what they do is a function is basically a machine, and they define what that machine's doing every single time. So here it says f of x is equal to x plus 7. Now what is inside our parentheses represents our x value, and then over here it tells us in our function what's being done to x. Alright, so an example like this where we're finding f of 10, 10 is our x value. So that's the value we're going to plug into our function. So wherever I have an x over here, I plug in 10. So f of 10, I replace the x with the value of 10. Notice when I replace it, the x doesn't appear anywhere in my function. Now, my original function says, hey, we're going to add 7 to whatever x is. So what I'll get is I'll get f of 10 is equal to 10 plus 7. So therefore, f of 10 is equivalent to 17. Now, if I needed to write that as an ordered pair, the x value is what's inside the parentheses, 10, and then the y value is what it's equal to. Just like 17 here, it's equal to y. So the ordered pair for that point would be 10, comma 17. Now, down at the bottom, what I did is I found f of y. So this is kind of crazy, but what I'm going to do is wherever I have an x, I'm going to take out the x and in its place put y. So our function tells us to add 7, so I'll say y plus 7, so that'll be my answer. So f of y is equal to y plus 7. Let's look at another example. Here we have g of x is equal to x squared plus 3x plus 4. So whatever's inside my parentheses, I will come in and I will replace the x with that number. Now, my function tells me this. It tells me whatever number I plug in, I will square. I will multiply by 3 and add it to x squared, and then I will add 4 to it. So in this first example, I'm trying to find g of 2. So I'm going to take that 2 and replace it in for x here, and also replace it in here. So now when I plug in and find the g of x, okay, g of x, now I'm going to find g of 2, so again I replace it, and I just need to do order of operations. So when you square 2, you get 4. Here, this will give me a positive 6, and then plus 4. So when you combine those, you should get 14 as your answer. So g of 2 is equivalent to 14. To find g of negative 1, again, I'm going to plug it in. So wherever I have an x, I'm going to replace that with negative 1. And whatever was being done to x in my original problem, it's being squared, multiplied by 3, and added by 4, I'm going to have to do the exact same things to negative 1. Make sure that you write this in your calculator correctly. If you just write this, if you write negative 1 squared, your calculator will tell you that answer is negative 1 because you need to square the negative also. So you'll get 1 and then minus 3 plus 4. So it's going to be 5 minus 3, which should give you 2. Now in the bottom one, a little bit more difficult. This time what we're doing is we're plugging a binomial in for x. So same concepts, just the math is going to be, the algebra is going to be a little bit more difficult. Okay, so when I plug it in, again, I'm going to square it because that's what it tells me to do to x, multiply it by 3, and then add 4. Now, squaring a binomial, as you guys know, just a little sidebar here, you need to write it twice and multiply it by itself. So when you do that and you work it out, you should get x squared, and then this will give me x times x squared. This will give me negative x, and that will give me negative x. So we put those together, negative 2x, negative 1 times negative 1 is positive 1, and then plus 3x minus 3 plus 4. So when you combine all your like terms, you'll get g of x minus 1 to be x squared plus x, and then let's see, 5, so it'll be plus 2. There you go, evaluating a function.